In this lesson, we're going to learn some really basic information on oxidation-reduction reactions. Hopefully, if you have page 90-91 set up, I would like you to add something over here on page 91. I would like you to write that oxidation equals loss of electrons, and reduction is equal to gain of electrons. We use the acronym OIL RIG. Oxidation is loss, reduction is gain. I'm going to, in this video, talk to you about these general statements about assigning oxidation numbers. And then we'll do two different lessons, one on assigning and then one about these reactions. So let's all take a look at this first chart that you have, and we're going to go through these statements one at a time. So what these actual statements are the oxidation numbers. These are going to be the oxidation numbers. If an element is in its elemental form, its oxidation number is 0. And then here it tells you it means that only one kind of atom present, it has no charge. If we have atomic ions, the oxidation number of atomic ions equals the charge on the atom. This is for monoatomic ions only. Then we have group 1A, which includes lithium, sodium, potassium, rubidium, and cesium. They all have a positive 1 charge unless they're in their elemental form. So if you have sodium, it's going to have a 0 for an oxidation number, but if it's a sodium ion, it's going to have a +1 charge. And we already know that everything in group 1 has a charge of +1 when it's an ion. Only when it's an ion. All right, group 2, so these are our group 2A. We have beryllium, magnesium, calcium, strontium, and barium. And they all have a +2 charge unless they're in their elemental form for their oxidation numbers. Hydrogen, when bonded to a nonmetal, has an oxidation number of +1 because that is when it's acting like a metal, and it can have a -1 when bonded to a metal, which makes sense. It would have to be negative. We in this class are mostly going to deal with hydrogen acting sort of like a metal. It's not a metal, but acting like a metal. Oxygen has an oxidation number of -1 in peroxide. So this is a peroxide. If you look on your polyatomic ion chart, peroxide would be there, and it would be O2 -1. So a peroxide is a polyatomic ion. Polyatomic ion. This is what you're normally going to have. It's -2 in all other compounds, and it's the most common. So that's oxygen acting like an oxygen ion, which we've already dealt with. Has a -2 charge because it's in group 6A, and it needs 2 more electrons to get an octet. Fluorine's oxidation number is always -1. All right, neutral compounds. The sum of all the oxidation numbers of atoms or ions in a neutral compound is 0. So neutral compounds. That's most of the chemicals you're going to find in chemical reactions, and we'll take a look at that in a second. Ionic compounds. The sum of all oxidation numbers of atoms in an ionic compound is the charge on the polyatomic ion, and we will talk about that also. This chart should be on the top of your notebook, page 90. It is a resource for you.